All right, so we're going to look at a special property of inverse functions, and that is what happens when we compose or do the composition of inverse functions. Okay. So we alluded to this a little bit earlier when we looked at graphing these, and we said, you know, the inverse function, this becomes the independent variable, and this becomes the dependent variable, and then vice versa. And if you have x and you apply f, you get a y value. And then if you apply the inverse, f inverse of y, it'll take you right back to the same x you came from. Okay, so this is going to give us some insight into this property. So the functions f and f inverse are called inverses because they undo each other when you compose them together. So in other words, if you take f of f inverse of x, you should get x, and f inverse of f of x also gives you x. So if you were asked to verify that two functions are inverses, you actually need to make both of these calculations here. Okay. All right, so we have f of f inverse of x and f inverse of f of x for this original one that we did here. So y is equal to 3x plus 2. And let's see, f inverse is this x minus 2 over 3. So f of f inverse of x is going to be f of, let's see, x minus 2 over 3, which is 3 times x minus 2 over 3 plus 2. So I plug this in for x here. Those 3's cancel out. I get x minus 2 plus 2, which is equal to x, which is what we want. And then f inverse of f of x, so this will be f inverse of 3x plus 2. I'm going to put 3x plus 2 in for x here. So I get 3x plus 2 minus 2 over 3. So this plus 2 and the minus 2 cancel out. And I'm left with 3x over 3. The 3's cancel out, and I'm left with an x. Okay. So these should take you right back around to the same place you started at if they are truly inverses.